Over the next few slides, we are going to introduce you a variety of different use cases around specific IoT products and solutions people have developed. Previously, we talked about the domains and application areas in general. Now we are going to go through a few selected IoT products and solutions. So each of these slides you are going to see will most likely have some kind of multimedia link, most likely a video. Please go through that video so you can better understand the application. I'm not going to explain what is in the video, but I will briefly introduce what each IoT product is designed to do. In this one, you are going to see a wearable technology where a contact lens developed by Google with another company, where they have miniaturized a sensor and antenna, and they put them in between a contact lens, and then they develop this smartphone application where the contact lens send the glucose level in human tears into the smartphone in real time. So this is useful for monitoring glucose level in human body in a continuous way, which is useful for patients, especially the diabetic patients. This use case is about a very, very small ant-sized radio developed by Stanford and Berkeley. From the image, you can see that the small radio is put on a small coin. So you can see that it's very, very small compared to the thumb. They call this radio is a radio of an ant. So the device is self-powered. It's gather all the power it's need from the same electromagnetic waves that carry the signal to its receiving antenna. So there is no batteries required. So this is one of the smallest radios developed in the marketplace. Please go and watch the video to understand the product in more detail. So in this use case, they talk about a flexible heart sensor, which you can put on the outside wall of the heart, which will monitor the irregularities of the heart rhythm to identify any disease. And it can also monitor the pH level, which change if the blood supply changes or any kind of restriction. So you can pretty much detect early warnings of a heart attack where the blood supply to the heart has been blocked or restricted. Please watch the full video to understand these particular solutions better. This use case is focused on smart buildings. Smart buildings are a very big portion of Internet of Things technologies. In this particular use case, they talk about monitoring air quality and have sensors to flag any cleaning required. You can actually monitor the particles in the air and see whether it is too much dust that need to be cleaned. And it is fully powered by solar panels. They have used LED lights to powered by Ethernet, where Ethernet is used for both power and the data communication, and then having powered the all smart technologies using the Ethernet cable without having wirings. In this use case, they talk about the Barcelona smart city. There are a few features they talk about in this particular use case, such as dynamically managed street lights, Wi-Fi on public transport, parking space sensors to reduce traffic. They also talk about how they use real-time data to fight public property problems such as graffiti, pollution, and littering. So please go and watch the video to understand how Barcelona has developed a smart city. This is a autonomous vehicles based use case where they have developed a smart autonomous bus where they can transport people around the campus. Key focuses has been efficient travel times, energy savings to reduce in the road toll, increase mobility for elderly people while reducing the carbon emission. So please go ahead and watch the video about this autonomous bus. This use case presents a scenario where they talk about Sydney Harbour Bridge. Sydney Harbour Bridge is an iconic structure in Sydney, Australia. They have deployed around 3,200 sensors underneath the bridge, including vibrations, to understand and monitor any kind of anomalies or any perform predictive maintenance. They have connected these sensors using fiber optic, and they use the data to analyze real-time performance of the bridge. Please go and watch the video to understand this use case better. In this use case, we talk about a dairy farm and how they use Internet of Things technologies to manage livestock. So basically they deploy IDs for each cow so they can remotely monitor and track each of the cows separately. And then they use this information for milk production, management, and tracking. And they also use a series of sensors to detect cows' health issues through motion. So how they move, because if they are sick, they move in a certain pattern. So I want you to stop the video now and then go and watch this use case and come back. In this use case, it provides a very important message that they are not necessarily using IoT sensors to diagnose any illness, but what they are doing is they are tracking any anomalies that where human could intervene and needs attention. So this gives an important message for us that when you are developing an IoT solution, it is not necessarily about even solving the problem, but if you can selectively and filter out and bring the attention to the humans, that helps to make better decisions and decisions quickly, and then do some preventive mechanisms rather than trying to solve when it becomes a problem. This is a use case on agriculture. It is important to note that agriculture has been one of the first adopters, or even before IoT, people have been using sensor networks to monitor large areas of agricultural fields. So this is more like the second wave of technology, because they have been using sensors for a long time. Agricultural domain use sensors to reduce water and reduce any wastages. By doing that, to reduce labor and also to detect any diseases earlier in order to make actions to avoid them. I would like you to stop the video and go and watch the scenario that we have presented here. Precision agriculture is a variant of agriculture where the approach is to manage the farm using the information technology. It closely monitors the field, collects a lot of data, and then make the decisions based on the data. Previously, precision agriculture technology was implemented by large agricultural businesses because the upfront investment was larger, because in order to make decisions, you need to deploy a reasonable number of sensors and actuators within the field. It is not like you can deploy one sensor and a couple of sensors and start looking at the data and make decisions. If you're doing it a data-driven way, you need a lot of data, and a lot of data means you need to deploy a lot of hardware, which is a cost for a small business. But because of the IoT technology and reduction in hardware cost and open source software, these precision agriculture is becoming increasingly low cost and available for small farmers as well. The positive thing about precision agriculture is farmers do not need to rely on their gut feeling. So basically, when you become a farmer, you have some kind of gut feeling that you learn through the process, or you are family members telling you over the time from your parents, you gather knowledge and then you take them forward. The precision agriculture is to avoid such kind of decision making and only to make decisions based on the data rather than the gut feeling or the experience. So the data would capture the information that is necessary to make decisions about the soil quality, health of the crops, water, and then even predict the climate, and then allow them to make the decisions on water, which help to reduce water consumption. A traditional farmer may know when to put the water and when not to, because if you're expecting raining, you probably don't want to save the cost. But in the precision agriculture, pretty much the systems will predict the weather and then ask you not to water. So these are the kind of decisions that data-driven systems can help the farmers to take on. Please go and watch the video on digital agricultural service to understand this domain better. This is a use case about healthcare, where they have developed a sensor-based system which you can wear on your leg, and the system will try to detect any anomalies in your gait patterns that would limit the movements of your body or tendency to fall. It also explained that how they built this low-cost, small and easy-to-use sensor system by themselves. I would like you to now go and watch the video where they explain their project. This is one of the use cases falls under Industrial Internet of Things. In this use case, they talk about smart monitoring and asset management related to wind turbines. So they were talking about how to predict failures within the components in wind turbines. So if you predict that, you can automate the supply chain, because these wind turbines are usually deployed in middle of nowhere. So if you can predict if a particular component is going to fail, you can arrange the whole logistic and make sure that the entire system is running in the most optimized way. So I would like you to stop the video now and please go and watch this use case about wind turbines and smart monitoring and asset management. This video is focused on disability management. So there are many people who have disabilities related to vision, hearing, motor or cognitive. So Internet of Things technologies has opened up new avenues and ways manufacturers and developers can develop software and hardware solutions to help people with disabilities. For example, smart home automation systems allows that to automation certain tasks where people struggle with motor difficulties or mobility. On the other hand, voice control has been used by like Alexa or Siri to give voice commands to devices or entire smart home automation systems. Please go and watch the video where a disability person is explaining how the IoT is helping him in his day-to-day life. This use case is about smart waste management. Two companies have developed smart waste bins, and they have replaced 840 bins with 80 large triple stations as shown in the figure. By doing so, they were able to reduce the collection 92.8%. So the collections per day has gone down from 3,360 to 240, which saves significant amount of labor costs. Typically, these smart waste management bins, they basically work with ultrasonic field sensors, cellular IoT to communicate with the main cloud platform. They are usually solar powered. Then also they have the capability to predict patterns and to predict when the bins will get filled based on the past data. So I would like you to stop the video now and go and watch this use case and come back. This use case focuses on smart street lights. Basically, they have developed a smart street light system where they use lights and motion sensors to automatically switch on the lights when someone is moving close by. They use both cellular technology to communicate the data, as well as they also create a real-time mesh network to pass the data around from street light to street light. So someone moving around the road, the street light get information quickly from each other. And also it helps to save energy and also help to reduce light pollution, because now rather than completely based on light sensors, it also based on motion. So you can dim the lights when nobody is there, and then increase the light when someone is nearby or a vehicle nearby. And then it also helps to reduce maintenance and faster replacement. So I would like you to go and watch the video and then come back. Next use case is on smart street parking. As you can see in the image, they have used infrared and magnetic based vehicle detection sensors mounted on the road surface to detect whether someone has parked or not. And then the parking sensor communicate with the nearby communication stations in lights using Zigbee and LoRaWAN technologies. And then using a mesh network, it passes on the messages or the data to the control center. Then the control center put the data in the cloud, and then the drivers can see the empty parking slot through their mobile app, and they also proposed a dynamic parking pricing. By developing this system, they have reduced the time it takes to find a parking slot, and also save a lot of time, fuel, mental health, well-being, and pollution. It has been identified that more than 30% of a city's traffic is caused by the drivers who are looking for a parking spot, because increasingly cities are becoming more and more complicated to navigate, and there are a lot of people coming in looking for parking slots. Every usual parking space or large parking areas are typically consumed by the buildings. So it has become quite challenging for drivers to find a parking slot. For example, in New York City, 29% of the commuters says that they spend average about 20 minutes to find a parking slot. Now please go and watch the video of the use case that they explain how they built the system. This use case focuses on surveillance and security. So what they have done is they have developed a real-time analytics that AI is actually monitoring the behavior of objects in each video frames rather than humans monitoring. Especially they have focused on edge-based analytics, where the video processing actually happens on the video camera or very nearby station rather than sending data to the cloud. By doing so, they have managed to maintain the privacy because the data don't leave the edge device. It gets processed and it only send the information to the cloud if it detects a particular anomaly. And also it reduces the human labor, where otherwise some security expert need to look into all different video streams. And also it helps to gather information about the number of people, density, velocity, direction, those kind of things which is not practical to monitor or measure using human experts. So please stop the video and go and watch the use case video presented here. This use case focuses on connected vehicles. As you can see on the image, there are different kind of communications happen within connected vehicles domain. First, it could be vehicle to pedestrian, or it could be vehicle to vehicle, or it could be vehicle to the infrastructure, or a vehicle to anything else like traffic lights. So basically the idea is that these objects are communicating with each other to make sure that accidents are avoided. Each of the devices know the presence of each other, so they can take measures. For example, if a pedestrian is coming by closer to a crossing, then the crossing can actually tell the vehicle coming in and warn them, maybe even automatic braking. Even the vehicle may not see the pedestrian for some reason. It is important to understand the difference between V2X communication and the autonomous vehicles. So typically when we talk about autonomous vehicles, we think about a bunch of sensors within the vehicle looking outside and also observing the vehicle components and make sure that everything runs smoothly, and then also try to avoid any accidents and then try to reach the destination. In the V2X domain, what we are talking about is external objects communicate with the vehicles by providing the information that it would not get otherwise. So the sensors within the vehicle, which observes internally and looking outside externally, has some limitations. It has cameras, it has lidars, but it has limitations that what it can observe around the environment, especially far into the distance. V2X means that a traffic light or any other object that resides far ahead of the vehicle that the vehicle sensors will not pick up, but the communication would still happen and sending some warning saying, okay, there is a road work going on far ahead in the road or something like that. So this is where the Internet of Things come into play, and then why it is really important and useful. I would like you to now stop this video and go and watch the use case video presented here. Similar to the connected vehicles, this is a scenario where we call Internet of Cars, where the idea is that rather than having own your car, you basically call your autonomous car, and then the car arrives and you get on. Either you will drive the car or either the car will drive itself, and then you get dropped off in a particular place, and that is it. So you no longer need to have your own vehicle, which is sometimes really inefficient because you might not use the car most of the time and it will be parking somewhere. So in this concept of the Internet of Cars, the idea is that nobody owns a car, but when anyone wants a car, you will order a car rather than someone driving the car for you. The car will automatically come to you. So this will reduce the number of cars overall that we need to have, because we no longer need cars for being parked on parking spaces, because all the cars can use it to the maximum potential. This is a use case about baby monitoring and activity tracking. So what they have developed is a sensor that attached to the baby's clothes, where it monitors the baby's position and wake and sleep patterns. It has sensors to measure and monitor both breathing and oxygen levels, and also it tracks skin temperature and the ECG. So they use the sensors to connect through a mobile phone, and through a mobile app, parents can real time see the inside, and over time they will also get reports. I would like you to stop the video now and go to and check the video about the baby monitoring system. This is another use case about baby monitoring. The idea is to track any urinary tract infections. They have developed sensors that can be put on the baby's diaper, and then the sensors are basically urine activated paper based batteries, and they are designed to detect any infections. So typically the more traditional urine culture test is accurate, but it is time consuming. Dipstick test fast but high false alarm rate. So this particular solution stays in between and then try to detect any infection at earlier stage possible with low cost sensors. The reason is that urinary tract infections is the second most common infection in the body, accounting for more than 7 million office visits and 100,000 hospitalizations per year in United States. I would like you to stop the video now and go and watch the full video of the use case. This use case focuses on elderly monitoring, especially incontinent management. So basically they have developed a small sensor that you can put on a diaper where elderly people, especially in nursing homes, do wear. And then it will tell the care workers about when to change the diapers or any kind of infection signs. 40 to 60% of the nursing home residents usually suffer incontinence. Smart diapers allows caregivers to actually remotely detect that and change their diapers, which is convenient for the residents as well as help for nursing homes to manage more efficiently. I would like you to go and watch the full video of the use case. This is another elderly monitoring use case focusing on fall detection. 1 in 4 Americans age over 65 falls each year. These falls are the leading cause of fatal injuries and the most common cause for non-fatal trauma-related hospital admissions. So they have developed an IoT solutions to detect these falls as quickly as possible, which greatly benefit the elderly people. So the key contributions of this solution is to reduce the cost, improving the quality of life and the independent living. So I would like you to go and watch the full video about how they develop the system and how the system works. In this figure, they have explained one of the ways that they have developed these fault detection systems. So you basically use sensors, which is LoRa powered. We will be talking about these technologies in a later lessons, and then the data directly goes to the LoRaWAN gateway, and then move to the cloud, go to the cloud application or the network server, and then the care workers or the emergency personnel will get notified. This is not the only way. There are many people who have developed fault detection systems in different ways, and this is one of the examples people have developed the IoT solutions. Each of these solutions have their own pros and cons depending on the technology they use and then the cost involved. So it's basically a trade-off rather than saying what kind of solution is best compared to the other. In this slide, I'm going to introduce you to 3 different use case scenarios related to mood enhancement. On the first image, it shows a bigger house and 3 little houses. The idea is that these big house and the small house kid is in a parent's home. Assuming that children are living apart from parents, each of these little houses represent one child. And then when, for example, if the child is in university accommodation, when they come home, come to their apartment and switch on the light, the little house in the parents' house get light up to represent that their child is in their home, in the sense in their apartment where they live in. So basically this gives some kind of a closure between family members. So the parents know that their children are back in safe in their own apartments or flats or places. The other image is about a clock, which is again similar. The idea is that the clock stays in the parents' house, and then each arm represent a different child or a family member. It could be friends as well. And then the clock face is divided into different common places, like libraries or schools or hospitals, airports, and so on, or a gym. And then there are a mobile app that will actually track the location of these individuals, the kids or children. And when the children move through their daily life and they go to gym and grocery shop and come back home, these arm, the clock arm correspond to that particular child, moves around the face accordingly. So in this way, the parents actually get some kind of a sense or a connection by knowing that where their children are at in a particular given time. The third use case is about smart chessboard. I would like you to stop the video and go and watch it. Basically, it is similar to the chess game in computer, but instead here there are 2 people in 2 different places, but connected to over the internet, and then you can physically move the chess pieces, and then the smart chessboard mechanically will replicate your moves to the other person. So all 3 scenarios has a common theme or objective around managing loneliness, entertainment, and safety, and stay connected. This is a use case about sleep monitoring. Sleep is a very important thing, and it is important to understand how we sleep and what is the quality of sleep we are getting. So this particular device is something that you can lay across your bed, and then it has a bunch of sensors, and it will measure our movements at night while we are sleeping, and also record number of other parameters using sensors such as heart rate, breathing, and snoring. And it will create a report about the quality of the sleep we get, so we can change our habits or change our beds or the time we sleep and so on. I would like you to stop the video now and go and check out the use case video about a particular IoT solution. It is important to note that there are many sleep monitoring IoT solutions. This is only one. As I said before, each solution is different. Sometimes they are wearables, sometimes they are attached to the bed, sometimes you keep it on the side on a table. There are many different ways that people have developed invasive and non-invasive ways to monitor the sleep patterns. In this slide, I'm going to talk about two different disease treatment and progress monitoring use cases related to Parkinson. Parkinson is a serious disease which impact large population around the world. And the patients with Parkinson disease, it is something that could deteriorate over time. So they need to be continually assessed in order to keep up with their symptoms. And also these symptoms could also fluctuate. So in this particular use case, they have developed a spoon, which is a smart computerized handle, which actually allows them to eat much more conveniently than a traditional spoon. I would like you to go and watch the video to understand how the technology could help with patients who have very challenging diseases like Parkinson. This is another mobile application that use motion sensors, audio sensors, and camera sensors to help measure the spatial memory, tapping intervals, and their ability to speak. So typically, there are designated mobile applications that the patients are being evaluated using those applications. However, the IoT technology has been developed to continuously monitor these factors in a non-invasive manner. So rather than you measure these parameters in a predefined time frames, the IoT helps to monitor these parameters in a continuous and progressive manner, which is greatly benefited by the patients. This use case focuses on enhanced adherence. 84% of the US healthcare spending on patients with chronic conditions, but more than 50% of the prescribed medication are not taken directly. And one of the key issues is that people forget to take the medication. So to address this issue, a company has developed an IoT solution where they have embedded a small sensor into the pill itself. And when you take your medication, the pill goes to your stomach, and then the stomach fluid activates the sensor and then send a message to your mobile phone. Basically, you need to stick a patch on your stomach, which the pill or the sensor in the pill is going to send the data to that patch, and then that patch will communicate to the mobile phone. So in this way, the mobile app will track whether you took the medication or not autonomously. So you don't have to keep it in memory. Please stop the video and go and watch the use case video. This slide presents a use case scenario related to smart manufacturing and supply chain management. Manufacturing and supply chain is a big part of Internet of Things. One of the early adopters. They use IoT sensors within their manufacturing process to help their robotics to detect any anomalies or do predictive maintenance in order to replace parts within the manufacturing systems before they fail. And also IoT sensors are being used in the supply chain to monitor the goods or the raw material. So you can track from the farm or at the very beginning of the ingredient until it comes to the manufacturing flow. And then also you can monitor from the point that it leaves manufacturing flow to the supermarket, to the end user. So you can use different IoT solutions to track these movements across the supply chain. IoT technologies help to increase the efficiency and reduce the fail time, increase the capabilities, and they are very good or efficient at performing certain tasks. I would like you to now go and watch the use case video on smart manufacturing. Additionally, I have explained the smart manufacturing scenario in this figure. In this slide, we present a use case scenario on ubiquitous payment. Most of you may have used bank cards where you can touch and pay. Instead of using bank cards, IoT solutions have developed where you can touch your armband or wristwatch instead of the bank card, which brings more convenient, but also it helps people to use multiple devices to make the payment rather than depending on one single bank card. Additionally, you can also integrate your bank card to your car, and then ideally when you go for filling your tank, it will automatically recognize your car and the bank, and it will automatically do the transaction. In a more futuristic scenario, you will also be able to buy your order, your groceries from home through a smart fridge or smart kitchen appliances, where they are directly connected to the groceries web platforms, and you can do the ordering directly rather than going to your computer and then visit the particular website of the grocery store and then do the ordering there. These devices need to be context aware, and they have your profile embedded with them, so they know your patterns. So in case if someone trying to mimic you, these devices will actually detect as a fraudulent transaction. One downside would be compared to a bank card, these devices may depend on batteries. For example, your watch, if the battery goes down, you might not be able to do the payment. But that is why ideal systems need to support multiple devices and look at these devices as a continuum rather than one device. So you can pay across different devices, from smartwatch to your car to the kitchen appliances, or when you are in the living room, you can buy things from the smart TV. And also these devices are helpful to do the payments in public and private places. For example, there are grocery stores where you can go and pick whatever you like and then go out. It will automatically detect who you are, and then it will automatically deduct from your bank account based on what did you pick. So smart cameras and AI technologies has been put together to identify what you have bought in the particular grocery store. Similarly, there could be many up and coming technologies in this area. I would now like to invite you to watch the video attached to this use case to understand the domain better. This is a very special use case related to food production. I named this slide as a useless product, which means that this is a very good example why you should not develop IoT solutions for the sake of doing it. So this is basically a product where it promises to give fresh juice. So you can buy the machine, quite expensive, and then you can put these small packets into that, and then the juicer will press it, and then the juice will come from the bottom hole. So that is the idea. But what happened is that they spent so much research and development which went to it, and then the cost of the device has to be quite high to recover this cost. But turned out to be that these packets can be pressed by hand, and then there's absolutely no quality difference between using your own hand to press the juice or using this particular machine. So the machine become completely useless, even though it was developed in the intention that to enable people to drink fresh juice. So the complexity is the enemy here. You will see in the video that they have put a lot of effort on engineering that. It is pretty much engineering first problem. So they have developed a mechanism to press this juice without thinking about actually anyone can press the juice packet by hand, and then the quality is exactly the same. And so this is a good example where why you should not invent a problem. Always need to think about what is the simplest way to solve a problem, and then only develop or thinking about developing a solution, especially IoT solution, if there is no other simple way to overcome the issue. So please go and watch the video on this use case. Finally, I would like to introduce some ideal characteristics of an IoT system. So this is not a complete list, but this is some of the fundamental characteristics that an IoT system should demonstrate. First one is the ubiquitous. So it should be everywhere, but it should be something that is noticeable. So it should be embedded in the environment, but without explicitly noticing to it somebody else. And the smart, the solution should be intelligent and demonstrate the smart behavior. It should be agile. It should be able to change based on the context, or based on the demand, or based on the requirement of the end user. And then it has to be on demand. So it should be able to there when the end users need it. And also it has to be secure. IoT system should be low maintenance, and also low latency, or it should act fast and respond to the users fast. IoT systems should be upgradable component wise, rather than having completely buying a new system. It could be upgrading certain hardware components, or it could be the software upgrades. And then IoT systems should be able to grow, which means that you should be able to integrate more and more components to it, whether it depend on smart manufacturing, or it could be smart home, where you first buy certain type of devices, and then you continuously buy more and more appliances and smart connected devices, and they get connected to the single smart home system without an issue. And then they has to be adaptable. So when you are away from home, the IoT solutions should be able to know that, and then adapt to it, and then maybe increase it security surveillance while you are at not at home, and also maybe reduce the temperature to save energy. So the adaptability depending on the circumstances is quite important. Especially another type of adaptation could be if one of the devices fail, maybe other devices or the other appliances nearby might be able to take over some of the parts of that. For example, if some of the cameras stop in a surveillance system, maybe opportunistically the doorbell camera might be switched on, and then look for any anomalies more proactively, which it would not do otherwise, because usually the doorbell camera might be only working during when there's a motion. But given that particular camera fails, now the doorbell camera replaces its role as a doorbell camera to a CCTV camera. So those kind of adaptations could be endless. There could be many different types of adaptation, and then all of these are the characteristics of an ideal IoT system. We have now reached the end of the lesson number 1, applications and use cases. I hope the applications and use cases we talk about in this lesson motivates you to think about and learn IoT further. The following lessons will give you more technical depth in a few different topics related to Internet of Things. I'm looking forward to see you in the next lesson.